Hello everyone. This is a short session on regression where we will be dealing with the basic concepts related to regression analysis. In this video, we will be discussing about the meaning of regression, the meaning of the term linear in regression analysis, and also the different types of linear regression models. So what is regression? The term regression was introduced by Francis Galton. And regression analysis is concerned with the study of the dependence of one variable on one or more other variables with a view to estimating and predicting the mean value of the former in terms of the non or fixed values of the latter. To put it in simple words, regression is the dependence of the dependent variable on one or more explanatory variables. Explanatory variable is nothing but your independent variable. This is a simple example for a regression model. It's actually a PRF, which is the population regression function. So here y is your dependent variable, which is stochastic. Stochastic means random. So y takes random values. X is your independent variable or the explanatory variable. It is non-stochastic in nature. What do you mean by non-stochastic? Non-random, not random. That is, either you know the values of x, they are given to you, or they are assumed to be fixed. Mu is the error term or the stochastic disturbance term. And why do you include the stochastic disturbance term into the regression? This is because we know that there can be other variables other than x which have an effect on y. So, the error term is a surrogate for all other variables which are omitted from the regression model. That is why we have the stochastic disturbance term or the error term. Beta 1 and beta 2 are the parameters or the regression coefficients. To be more specific, beta 1 is the intercept coefficient, beta 2 is the slope coefficient. So, intercept coefficient in the sense that when your independent variable takes the value 0, what is the value of the dependent variable? And slope coefficient shows the change in the dependent variable for a unit change in the independent variable. So, this is the PRF where there is the dependent variable, there is an independent variable, there are the parameters or the regression coefficients and a stochastic disturbance term. And the subscript I is added to include multiple observations. Now moving on to the term linear. See, when we hear about linear, generally what idea comes into our mind? We feel that when you hear linear, the curve that we get will be a straight line and also the variables and parameters will be raised to the power or index of 1 only. Now, when we consider linearity in regression analysis, we need to look into two aspects. Linearity in the variables and linearity in the parameters. So, what do you mean by linearity in the variables? Take this equation for example. Again, this is a population regression function. So, the explanatory variable here is x. What is the power of x? It is 1. So, this is a linear model where the power of x is 1. What about the second equation? The power of x is 2. So, this is non-linear. Okay. Now, moving on to linearity in the parameters. We know that the parameters are beta 1 and beta 2. So, they should be raised to the power of 1. Consider the first equation. Beta 1 and beta 2 are raised to the power of 1. So, it is considered to be a linear model. Whereas in the second equation, beta 2 is raised to the power 2. So, it is not linear. So, what does this imply? A linear regression will always mean a regression that is linear in the parameters. It may or may not be linear in the explanatory variables. So, the important thing that you have to keep in your mind is linear regression means it should be linear in the parameters. We are not bothered whether the explanatory variable is linear or non-linear in nature. What we are bothered about is the linearity in parameters. So I repeat, linear regression will always mean a regression that is linear in the parameters. It may or may not be linear in the explanatory variables. These two equations, these two PRFs are an example for a linear regression model. See, in the first case, it is linear both in the parameters as well as in the explanatory variable. Whereas in the second case, it is linear in the parameters and non-linear in the explanatory variable, but it still can be considered as a linear regression model. Now consider these equations. These are examples for non-linear regression models. See, in the first equation, the parameter is raised to the power 2. So it is non-linear. In the second equation, it is non-linear both in the parameters as well as the explanatory variable. So a linear regression means linearity in the parameters. May or may not be linear in the explanatory variable. Now moving on to the different types of linear regression models. There are mainly two types: simple linear regression model and multiple linear regression model. In a simple linear regression model, you have only one explanatory variable or one independent variable. Consider this PRF. See, X is the only independent variable that is coming into this model. So it is considered to be a simple linear regression model. A simple linear regression model is also known as a two-variable regression model. But let me remind you that please do not get confused when you hear the term two-variable. Here two-variable denotes one dependent and one independent variable. So a simple linear regression model or a two-variable regression model contains only one explanatory variable or one independent variable. Whereas in the case of a multiple linear regression model, there can be more than one explanatory variable. See, in this example, I have taken two explanatory variables, x2 and x3. There is one dependent variable, y. Beta 1 is your intercept coefficient. Beta 2 and beta 3 are your partial slope coefficients. So to summarize, regression is the study of the dependence of the dependent variable on one or more explanatory variables. And linearity in regression means linearity in the parameters. We are not bothered whether the explanatory variable is linear or non-linear. And there are two kinds of linear regression models: simple linear regression model and multiple linear regression model. In simple linear, you have only one explanatory variable, whereas in the case of multiple linear regression model, there is more than one explanatory variable. That's all for now. Thank you.